My goal today is to do 3 different situations. We are going to look at finding the exact value of the slope of a tangent line to any given curve, y equals f of x, at some number x equals a. And so the generic version, and this is just repeated notes from last time, maybe a little bit prettier than last time. And what it essentially says is that if you're interested in this slope, this blue line here, the tangent line slope, you want to know what number it is. You pick another point Q, which is very close to it. Its x coordinate is called a plus h. And you find the slope joining P to Q, which is what this is. Then you simplify it a little bit, not much, but you simplify it. And then you do this little trick. You imagine that h becomes 0. Now, as h becomes 0, won't this point come to this point? So essentially, P and Q become indistinguishable from each other. And the logic says that if you're able to do that and come up with a number, what you're really finding is the slope of the tangent line. Now, we're using limits to avoid the 0 over 0, which is what you'd get if you just made them equal. But if you made them the limit as they become equal, you can get away with it. So the 3 guys that we're going to be doing and today are going to be polynomials. So we're going to use this to find polynomials. We're going to do it for radicals. And we're going to do it for rationals. And well, let's get straight into the first one. I'm going to pick quadratics because there's less algebra, but they're still big. There's a quadratic, and I would like to find the slope of the tangent line at an x coordinate of 4, which they will in the book call a equals 4. And will you just assume that a equals 4 is the same thing as the x coordinate is 4, right? It's just the way, there is a reason behind why they're calling it a. But you're finding the slope of the tangent line when the x coordinate is 4, right? They'll just say a equals 4 or a equals 2 or whatever. So the slope of the tangent line, which is called f dashed of 2. Isn't that a nice notation that says the slope of the tangent line at the x coordinate 2? It's a lot easier to say that. So f dashed of 2, which is, by the way, also called the derivative at 2. It's going to be the limit as h tends to 0 of 2 plus h, take away f of 2 all over h. And we are going to work through this, and we are going to get the answer, whatever it is, 22, 5, whatever. And that's our goal, to find what the slope at x equals 4 for this quadratic would be. So it's going to be the limit as h tends to 0. Right. If you want to find the value of the function at 2 plus h, it becomes 2 of this guy squared, take away 3 of this guy plus 1. So that becomes 2 lots of 2 plus h squared, take away 3 lots of 2 plus h, add 1. Take away f of 2. Well, f of 2 is the value of the function at 2. So what's that? 2 times 2 times 2, that's 8. That's 9. 9 take away 6 is 3. So we get 3. Let me check. 2, 4, 8, 9, 10. Yeah, 3. Are we good so far? So it's then going to become the limit as h tends to 0. Multiply that guy out and you'll get a 4 plus a 4h plus an h squared. Distribute this, you get negative 6, take away 3h, plus a 1, take away a 3. probably don't need all these lines, but I'm putting every line I can think of in. You now double all these guys, so you distribute the 2. Pretty ugly expression. Let's see what happens when you combine like terms. So I'm going to take that 8, that -6, that +1, and that -3. And what do you get when you put them all together? What do you notice happens?
Get 0.
You get a 0. And that is not a coincidence. They better always cancel out or you've screwed up. There are no numbers going to be left behind. So we're now going to have the limit as h tends to 0. Well, that and that gets me, what, 5h plus 2h squared. Isn't that a lot nicer looking than it was a minute ago? When you do this question, you never get on the top line things that don't have an h in it, right? So you'll never get a +4, for instance, or a +2a or anything else. Now, at this point here, I think it's pretty obvious what should happen. What should we do?
Cancel out the h.
Yeah, and before we cancel out that h, make sure that you pull it out as a common factor. Then you can cancel it. And that leaves you with the limit as h tends to 0 of 5 plus 2h. Don't say, oh, I'll just cancel this h with that h and leave 5 plus 2h squared. That algebraically is not correct. You can only cancel factors. So you have to pull something out as a common factor before you can cancel it so that it is a factor that's cancelling it. So the h factor is cancelling this h. Now, at this point here, can't we just plug in h equals 0 and get the answer 5? So the exact value for the slope of the tangent line to this quadratic at x equals 4 is 5. So you imagine the tangent line might be like that.
So when we did, so it's x equals 4. Why did we do f of 2 up there?
Okay, well caught. Everything is 2's. Right? I didn't even notice I did that mistake, but that is an easy fix. Can't I just change the question to do it at 2's? The math is correct. This is the correct answer when x is 2. Don't know. I put in 4 and then decided I was going to use 2 anyway. Go figure. Oh, well, maybe there's a reason why I might have chosen 4. If I wanted to do this same question, but I did want to do it with 4 or 10 or 22 or whatever, wouldn't I have to basically do an entire new question with very similar math, but with different numbers in different places, right? Can you imagine that that is a lot of work if you're working with one function and you're trying to find all sorts of different places along that curve what the slope of the tangent line is? Wouldn't it be nice if we could do a general version of this question? So instead of the x coordinate of 2, we could do a general version. And the answer is we can. So this is question 1 again. Same equation, but this time at x equals a. So I'm not going to make it 2 or 4. I'm just going to call the x coordinate a. Right? So The slope of the tangent line at the x coordinate equal to a is going to be the limit as h tends to 0 of f of a plus h, take away f of a all over h. When I say a, do you hear e?
Sometimes.
Yeah. Can't help it, so I speak. Because sometimes I have to spell things over the phone because people think I'm saying one and I'm actually saying the other. So let's see what happens here. For some people, I don't know quite why, but for some people, this is a bit awkward for their brain. Here is the function, and I'm going to evaluate it at a plus h. Essentially, I'm substituting the x for an a plus h. So instead of 2x squareds, you get 2 plus h squareds. Instead of take away 3x, you get take away 3a plus h. And instead of adding 1, you still add 1. You go with that. That's what f of a plus h is algebraically, right? Now, take away f of a. I'm putting a bracket around it. F of a is just replace the x with a, so 2a squared, take away 3a plus 1. Are you happy about that's what f of a looks like? This is f of a plus h, take away f of a. Why am I putting brackets around this?
Because you subtract the whole thing, and if you just put it, then you down, I guess.
You'll miss the other two probably.
Yeah, you'd get the wrong sides.
Yeah. So you need to make sure, and I think it's helpful to actually write this line with the bracket around it, because what that will hopefully do is force you to subtract all of these terms. Because if you don't do that bracket, you just write minus 2a squared, but you don't change these two. And you'll know that's wrong in 2 lines from now, because you'll have a plus 5 or something left over, and you're saying, what the heck's that doing there? There shouldn't be anything that doesn't have an h left over, or something will just not work. So let's continue this process. It's going to be the limit as h tends to 0. Oh, I normally wouldn't do this, but since this is notes, I'm going to put this line in as well. A plus h squared gets you that, so 2a plus h squared gets you that. I'll distribute the negative 3. There's the 1. And then I'll subtract all of these. So subtract that guy. If you subtract that guy, you get a plus. And if you subtract that, you get a 1. And then on this line, I'll distribute the 2. So I get 2a squared, 4ah plus 2h squared, minus this guy, plus 1. Take away that guy, add that guy, take away 1. Now that's a pretty massively ugly looking expression, right? Let's see what happens when we start collecting like terms. Okay. Do you notice that that 2a squared gets killed off by that? Anything else that gets killed off by something else?
3a?
3a.
Agree. Won't that 3a get killed off by that guy? Anything else getting killed off?
The 1.
And the only fellas that are left alive are that guy, and that guy. And do you notice that every single one of those terms has an h in it? So if you're doing one of these questions, when you get to this part, these terms all should have an H in them. So you're not allowed a +3 left over or a -2a left over. If you got little orphans like that, maybe you forgot to subtract properly, or maybe you didn't FOIL properly. You've done something, stop and fix it. Because if you try to keep going, it just doesn't work. So bear that in mind. Always going to be left with only terms with H's in it, or H squares, but at least an H. What do you think is going to happen? Yeah.
Factor out the H. It cancels. Just like before.
Just like before. So we are getting darn close to being finished. Can't I just basically replace H with 0 now? And what do we get? We get 4a take away 3. So the slope of the tangent line, the x equals a, is 4a take away 3. Now, although that was a little bit harder because I had to do more algebra and less numbers, now that I've got this answer, couldn't I find the slope to the tangent line of this fella at any number I like? For instance, at 2, shouldn't the answer be 5? Right? We already did this one, right? 4 times 2 take away 3, is that 5? Hey, it works. But couldn't I now do it for 40, for 4 million, for 1.2345? And isn't it much easier just to say 4 times the x coordinate take away 3 and get that answer than it is to fight your way through a really ugly number version every single time someone wants you to do it? Now, here is a side benefit. If I sketch that quadratic, I'm not making any great attempt to do it properly, but imagine it was that quadratic. There's a very interesting point on quadratics. You see that guy there, the vertex? If I draw the tangent line at that point, do you notice that the tangent line is going to be a horizontal line? Right? You imagine that when you get to the bottom of a hill or a valley, right? What's the slope of that?
0?
0. Now, if this guy over here tells me the slope of the tangent line at any given value, if I find out when is it 0, haven't I just found the coordinate, the x coordinate of that guy? So if you can find f dashed of a, not only can you use it to find what the slope is when a is 5 and a is 7, I can turn it on its head. Can't I find the x coordinate of a point where the slope's 0, which would tell me this guy? And I don't know why I'd want to, but if I wanted to, couldn't I also find the place where the slope was 12 or -40 or 1.2345? Because couldn't I just say, make that equal the number I just said, solve for a, and a is the x coordinate of where that would happen? So essentially, don't you know everything you need to know about slopes of tangent lines? And it's all in here. That's the beginning of the power of finding derivatives. That's what this guy is called, right? It's the slope of the tangent line at any given point. But that's a mouthful, so why don't we just say it's the derivative at 2, which is the same thing. And that is number 1 of the 3 guys that we're going to do today. Number 2 coming up. I'm going to do a radical now. And I'm going to do both versions. I'm going to do a number and then an a version. And when you go through your homework, you're going to get questions where you do a number and questions where you do a generalized a. This one here is going to be similar to question 1, actually. So f of x is the square root of 3x add 4, and we're going to do it at an x coordinate of 2. Again, why not? I would call that an x coordinate of 2, but they call it a equals 2, so it's the same thing, right? So the slope of the tangent line at x equals 2, or f dashed of 2, is the limit as h tends to 0 of f of 2 plus h, take away f of 2 all over h. That's going to be the limit as h tends to 0. Okay, here goes. This is the function. X is going to get replaced by 2 plus h. So what do I get? I get the square root of 3 lots of 2 plus h, add 4. Take away f of 2, 3 2's, you get 10 there. So 3 lots of 2, add 4, get you 10 over h. And then I'm going to write this fella a little bit nicer looking. There. Are you okay when you distribute and collect? That's what you get. Right, so this is the fella that we're going to have to find the limit as h tends to 0 for. I think it's obvious, but I'll ask a question anyway. What technique am I going to use to find this limit?
Conjugate method?
Correct. So it's the same two fellas, but with a plus. So far, so good? Now, what's that going to look like? Well, it's going to be the limit as h tends to 0. Don't do anything to the bottom. This guy times this guy. I could FOIL it out, but why don't I just do the shortcut? First guy squared, take away second guy squared. First guy squared is 3h plus 10. Take away the second guy squared is 10, right? Because if you square a square root, don't you just get the number inside? Right? This guy squared, take away that guy squared. And as we would have expected, and if we don't, we get worried, that doesn't the top only have h's in it? You agree the 10s cancel it? As they should. Can I just cancel those h's? We can now do the limit as h tends to 0. And this is what we have left. Okay, if you make h equals 0, doesn't that just become the square root of 10 plus another square root of 10? And that becomes 3 over 2 square root of 10s. Do you think I'm going to leave this answer like that? Even if Weber's sign does, I don't. So how are we going to fix it?
Multiply by the square root of 10 over
So
the
you're
square
going to
root of
get,
10.
yeah, you're going to get that guy. Exactly. And that's just prettier looking. So the answer to this question is the slope of the tangent line to this radical at an x coordinate of 2 is 3 root 10 over 20. There's no way in earth you could do that numerically, right? You might be able to tell me a decimal that's darn close to it, but you wouldn't be able to write it down as an exact value like this. And that was done at this point. So now we're going to do the same question again. What we're going to do at x equals a. So the slope of the tangent line at a is the limit as h tends to 0, f of a plus h, take away f of a all over h. Same math, essentially the same math. A little bit more awkward because there's less numbers, but that's about all. So it's going to be the limit as h tends to 0. Okay, square root of 3x add 4 becomes the square root of 3 a plus h's add 4. Are you happy with that? 3x add 4 becomes 3a plus h's add 4. Take away f of a. Well, if you replace the x with a, don't you just get the square root of 3a plus 4 over h? So far, so good. F of a plus h, take away f of a. Just going to make it slightly prettier. And maybe not prettier, but what it needs to be. Distribute the 3's. And now you've got this guy. Great. Okay. Aren't we still going to use the conjugate method? And if I'd planned ahead, I would have had enough room in here to put the conjugate. Can I just do dot, dot, dots with pluses, and you know it means this guy plus this guy? So what we're going to get then is the limit as h tends to 0 on the bottom this guy plus this guy. And on the top, if you take this guy and you multiply it by its conjugate, don't you get first guy take away second guy? First guy squared is this fella. Take away second guy. Do you notice that I've put a bracket round the second guy again? Same kind of reason as we did earlier. Don't we want to make sure we subtract both terms? Now, it's amazing. No matter how many times I've done this in my life, it's still kind of amazing to me that this happens algebraically. Because for something so ugly, you would think horrible things should happen. Let's see what happens. Won't that 3a be killed off by that 3a? Won't this 4 be killed off by that 4? And all that's left, and it's kind of amazing, isn't it? They just kind of disappear exactly the way they need to. Now I can cancel. We are left with the limit as h tends to 0 of 3 over this guy. Okay, almost done. You plug 0 in here. 3a plus nothing plus 4 just gets you the square root of 3a plus 4. This guy here is also that fella. This guy and this guy are the same guy. And that, in fact, is going to be the final answer. And you might say, but you went and did this guy and you went and rationalized the denominator, right? You did this thing over here. Why do we not do it here? You could, and it would be mathematically correct. And I hope WebAssign would accept it. And there is nothing wrong in you doing that. But let me show you why I don't. If I wanted to fix this, whatever fixing means, if I wanted to rationalize the denominator, essentially, then I would multiply by the square root, which is what you typically do. And I would get this answer. Now, the before and the after. Which one of them looks simpler? The before? So, yeah, style points do have rules, but don't we sometimes bend the rules to take care of reality, right? One of the rules is don't have square roots in the bottom, right? But can we have a kind of exception? Unless it makes it look so much uglier that it's better not to do it, in which case leave it alone, right? Now, with numbers, we don't have that flexibility, right? 4 over root 7 should be fixed, right? End of story, just fix it, right? But ugly expression might look worse rather than better if you fix it. So you kind of do a judgment call. So my judgment call is almost always going to be, leave that thing alone. Just leave it alone, call it good. How are we doing with this? Are you feeling comfortable about the process now that you've seen 4 versions, 2 with numbers and 2 with letter A? Right? That it should have a kind of flow to it, right? Even though they're different, a little bit different each one, don't they have a kind of this, then this kind of flow? And that's pretty much what I hope you're getting out of this so far. Our last one, let's do a rational. I'll warn you right up the front here. Rational functions are downright ugly. No bottom line here. I've never seen a nice one. They're never easy or smooth or pretty. They're always clunky and just downright awkward. So don't be surprised when you do rational functions, especially, that you're going to have problems. In my world, quadratics are easy. Right? They may be big, but they're easy, right? Square roots are pretty good. They're like a close second. And rationals, yeah, you don't want to do them unless you're forced to, right? They're just algebraically a pain in the butt. So I'm going to do this fella, and I'm going to do it to x equals 2 because everybody else is at 2. No particular reason. I could have done it at 42. It's not a big deal, right? So we're going to find the slope of this curve at x equals 2, or as they call it, a equals 2. So it's going to be the limit as h tends to 0 of 2 plus h, take away 2 over h. That's going to be the limit as to h tends to 0 of 3 over 2 plus h, take away 3 halves all over h. I think it's living up to its reputation of being downright ugly. I mean, it's already ugly. Would you agree? Fractions with fractions on the top are never going to end well, right? They're never going to be easy to deal with. There are 2 techniques for doing this. The first one is you just combine those 2 fractions by turning them into a common denominator, adding them together and deal with it. I'm not going to do it that way. You can look it up and see people doing it that way. And if you prefer to, by all means do it. I'm going to do it a different way. I am going to do this by multiplying this ugly fraction by a special version of 1. Now, if I multiplied the top and bottom by 2 plus h, wouldn't that guy just turn into a 3? That's good. Unfortunately, I've still got this 2. Okay, 3 halves isn't that big a deal, but I don't want halves anywhere, right? I don't want fractions at the beginning, middle, or end. I want them gone. And so to make that happen, the special version that I'm going to use is 2 lots at 2 plus h. Now, since I'm multiplying by a special version of 1, doesn't that mean my new answer is the same value? It'll just look different. And if you're wondering where did these come from, aren't they just these 2 guys? So the 2 denominators. So next line, the limit as h tends to 0. These 3 guys in the bottom, I'm going to write them down like that. Just shuffling the order. Now, I'm going to do this at the side because for some people, I know they have issues with fractions, I guess, in general. This is the guy, right, him, and he's going to be multiplied by him. Can you see what happens is 6? You comfortable about how this guy times this? And don't worry about the bottom. The bottom doesn't enter into this question. It's already accounted for. It's already down here, right? So you're just going to multiply guys in the top and nothing else. So that guy gets you 6. What would this fella times that get you? Well, let's see. You got this fella and you multiply it by that. Don't the 2's cancel? And you're left with -3, 2 plus h's. Great. Right, took a bit of kind of magic here, this special version of one trick. By the way, that's not the conjugate method. Wouldn't it be square roots? Although, can you see it's kind of like the conjugate method? You just find a special version of one to make things look pretty. So what I have now is the limit as h tends to 0 of 6, take away 6, take away 3h. We're by the worst, right? We're by the worst. Can you see something nice happening on the top? Can you see the 6's cancelling? And what that leaves me is that guy. And just like every other situation, shouldn't you reach a point where you've got a fraction where the top has nothing but h's in it? What's going to happen next?
Factor out that h.
Well, cancel it out.
Yeah.
Gotcha. So what we're left with?
Yeah, don't have to factor because it's already out.
Yeah, I kind of knew what you meant. That's what's left, right? This is good to go actually. If you make h 0, which is what I'm about to do, don't you get -3 over 2 times 2 plus nothing is still 2, and you get the answer -3/4. So for that rational function at an x coordinate of 2, the slope will be -3/4. You still with me? Okay. Last question for today. Same guy, x equals a. So the derivative at a is the limit as h tends to 0, f of a plus h, take away f of a all over h. It's going to be the limit as h tends to 0. Okay, plug a plus h and you get that guy. Plug in a and you get that guy. Okay, what special version of 1 is going to fix this ugly top?
A times a plus h.
Agreed? Do you see it's just the two denominators, a and a plus h? It seems to be going smoother than I expected, which is a good thing. Okay, if you take this fraction and you multiply it by this guy, and if there's too much going on, I'll just kind of write it down for you. If you take the first term, which is this fraction, and you multiply it by these guys, can you see that what you get left is 3a? And maybe you should have, just like I did, have a bit of scratch paper for some of these if it's kind of hard, you know, to visualize it because there's so many moving parts here that you might miss something. So that guy became 3A. And the second one, which is this fella, can you see that in this case, you get the answer -3 A plus H's. So this one is -3 A plus H's. Now don't you start cancelling things top and bottom, not a good idea. What you need to do instead is distribute and collect like terms. So 3A, distribute. And then, just like magic, haven't you got to the point where you've got a fraction where the top has H's in it and nothing else but H's? Exactly what should happen. We're damn close to finishing, aren't we? By the worst. Cancel. You're now looking at the limit as H tends to 0 of this guy, and what's left in the bottom are these two guys. But I can find the limit of this expression because I just need to make H 0, and I get -3 over A. Well, that's just A then, isn't it? So -3 over A squared. Let's do a check. Remember we did it with 2 and the answer is -3/4? Okay. Well, what do you get if you put 2 in here? Oh, -3 over 2 squared, -3/4. Couldn't you put 40 in there and get the slope at 40 and 77 and any other number and you're good to go? What would happen if I tried to do the tangent line when A was 0? That would mean the X coordinate was 0. What would the tangent line look like? What would the number be? It's 0. Well, what's -3 over 0?
Would it be like positive or negative infinity?
Yeah. And what does a positive or negative infinity look like? It looks like a vertical line. And isn't a vertical line a vertical asymptote? And where is the vertical asymptote happening? Isn't it happening at 0? So it's matching what we know to be true. If a function has a vertical asymptote, won't its derivative be infinitely big at that point if you tried to calculate its tangent line? And you can't really get, infinity isn't counted as a number, right? So you can't really get the slope of the tangent line, but we can visualize it, meaning it's vertical. Wouldn't that be a way of finding vertical tangent lines? And you say, well, you only get vertical tangent lines when you've got vertical asymptotes, or do you? Well, the answer is no. You can get vertical tangent lines in other cases. Do you know if you do this, the cube root of x function? Do you know the cube root of x function looks like that? Do you know x equals 0? The function is vertical. It does have a vertical tangent line. So vertical tangent lines do happen because you've got vertical asymptotes. But can you imagine that they could also happen in other ways? Do you know if you do the top half of a circle? Right, that would be the square root of 9 minus x squared. Do you know at that point there and at that point there, the tangent lines are vertical because the circle, right when it hits the x-axis, goes vertical on you. Right? The curve is a vertical value. So what that allows us to do now is to have more insight into functions. Because can't we look at this fella and say, I wonder when it's infinite? Right? For what value of a, which would be the x coordinate, would you get an infinite answer? Right? Would you? And maybe you would suddenly discover that some functions had vertical tangent lines at places you never even thought of looking. Okay, I think we've learned some cool stuff today, and I am getting better. 15 seconds. Go for it. Say hi and bugger off, because I want to make sure I finish this class exactly on time. Go, quick. Hi and bye-bye. Well, I guess if you have to stay by for some homework questions, you should, but bye-bye. Okay, Jesse, Thomas, do you have a question for me?
Yeah, are you still grading my test?
It is graded, and if I thought I sent you, but maybe I haven't. If you shoot me an email, I will send you your updated grade with your test score in it.
Okay, thank you.
Jesse,
So
what you got?
on homework 2.6, it's number 14.
Right.
I wasn't quite sure how to solve it. It
Okay,
looks
do
like
you have
something we've
a
probably
copy
been
of
taught.
it? Could you just read it out loud?
Yeah. So on the top of the fraction, it's 64 minus square root of x. And then the bottom is 8 plus square root of x.
Is this a limit expression question?
I think it was a limit to infinity.
Okay. Oh, interesting. Okay. Now, normally you would have polynomials and you divide by the highest power of x, but I'm going to use the same technique. I'm just going to divide the top and bottom by the square root of x. Right? So what we're going to get is the limit as x tends to infinity. That guy is going to be rather yucky, that fella, -1. And this is going to be kind of yucky guy, +1. So far, so good. Right, now I'm going to do brute force. I'm going to make x infinite. Okay, 64. Would you agree that the square root of infinity is still infinite?
Yeah.
And 8 square root of infinity is still infinite. What's 64 over infinity get us?
Pretty much 0.
So what you're going to get is 0 take away 1, 0 plus 1, answer -1.
Okay. Yeah, it just looked different from the things we had done.
It does. But, you know, they could have done this to you. And in this case, divide top and bottom by e to the 3x. And you'd get, actually, you get -1 in this one as well.
I think it just kind of threw me off that there wasn't any power of x besides just x itself.
Yeah, but technically it's x to the half if you're going to be
that's
nitpicky.
true. I didn't think about it like that. That's a good way to put it.
Okay.
All right. Thank you.
You're welcome. Bye-bye.